So for the next one, I'm going to talk about a topic that's kind of tied in many ways to microservices. Both of my other topics are tied to microservices in many ways. And this is one on event sourcing. Event sourcing is a term, it actually is a term I came up with to describe a common pattern. Well, a pattern that I saw a few times in information systems, but one that I felt wasn't used as widely as it could be, and still isn't used widely as it could be. So what is it? Well, the basic explanation is, I think, pretty simple. Let's imagine we're building a system that manages people's addresses, simple address book. And somebody wants to say, okay, I'd like to change my address, please. You've got a simple relationship between some kind of person record, some kind of address record. What do? You just blow away the old address record, create a new one, hook it up to the person. That's basically how you work that kind of, that's basically how we mostly do our systems. We make changes to our data stores. Now the event sourcing system puts in a slight variation to this. So faced with that same question, I'd like to change my address, what do we do here? Well, we actually divide our view of the world into two bits. And the first thing we do when we change our address is we create an event that captures this change, summarizes up what the change should be. Then we apply this to the same database that we had before and actually make the change. So what we've ended up is dividing our store of knowledge of the world into two parts. An application state, which is the current state of the world, and a log of events, everything that's ever happened to change that world. And it has now this sounds kind of like just kind of some audit or logging function, and of course the term event log kind of reinforces this. But it's not just like a regular logging situation, because there's another key characteristic of an event source system. And that is at any time I can blow away the application state completely, and then I can replay it from the event, replay the event log and rebuild that application state. And I can be confident that I have a usable application state as a result of that. And that's the characteristic that makes it event sourced. The events are, in the end, the fundamental source of truth. Though we can always go back to them and rebuild our application state. So, hands up. How many of you built something that's done this approach? Build a system with this approach? A few people, okay? How many of you used a system that uses this approach? Put your hands up if you've used a system that works this way. Okay. Put your hands up if you're a programmer, computer programmer. Put your hands up again if you've used a system that have used this approach. Now, a few more are sticking your hands up now. You're beginning to realize there's a trick question here. Every programmer these days should have used a system that uses this approach. Could I hear some examples of it, please? Yes. Basically, any source control system operates this way, right? Any source control system has, at least logically, a history of all the changes you ever made to your source code system, and you can rebuild your current state at any time. Right? You guys go git checkout master, or because we all use git these days, right? And you build your application state. Essentially, that's the essence of event sourcing. It's treating our data the way that we treat our code with a source control system in place. And in fact, most questions that come to event sourcing can actually be resolved by saying, well, what does a source code control system do? And most of the benefits, and to some extent the costs, can be analysed by thinking of that way. Now, I'm not going to really talk very much on the how you build this, because that's its own topic, and I'll explain a bit more about why I don't talk about it at the end. I'm going to focus a little bit more on why this is worth investigating, why you should think about doing this for some of all of the system that you have. Now, one reason that probably leaps to people's mind right away is that it gives us an audit trail. Right? Every change to our data is logged, which would happen in any kind of logging system, of course, but it's logged in a particularly strong way because we're relying on it as a source of truth, because it becomes a processable log. we have much more confidence in it than we have in just something where we're just writing off to a text file somewhere. And it's again, just like with our source code. We have to rely on that history in the source code repository. And we do rely on it to a great extent because we know we can run it anytime to build the state of our system. So that's the first reason. And that's actually quite a powerful reason. If you're in a situation where auditability is a crucial aspect of your data, this is immediately something to consider. That's going to give you a lot of auditability. And if you think about it, this is how accounting transactions work. If you've ever done any stuff in accounting and posting of entries and double entry bookkeeping and things of that kind, you know that you don't think about posting, you don't think about just crediting or subtracting or adding to a balance is not how you do things. You create posting entries that you don't change and you add them up to get your balance. It's the same principle. And in fact, that's in many ways how I first came across it, was working with accounting systems. Another great advantage of this approach is that it gives you a really powerful debugging technique. What you can do is you can take your system and you can take a production system and effectively copy it into a lab. And then see what happens in terms of something went wrong. So if something goes wrong, you take your copy of the system and you replay the events. And you can see, you can add extra monitoring code to find out what's going on. You can replay more than once. It gives you a great ability to replay what's gone wrong in a system. And I've often heard people say that this can be a really, really nice way, because I'm no longer relying on how good with my log messages in the logging side of things. I can actually replay events and manipulate and see what happened in a really rich debugging environment. So that's the second reason for using this, is debugging. The third reason would occur to you pretty much immediately if you're thinking about source code control. Because we've got this notion of event log and an application state, we can take the event log, we can wind it back to the beginning, and then wind it forward to any intermediate state. If we want to say, what did our view of the world look like 6 months ago, we can just do this. We've got an ability to do historical querying that's much, much more powerful than a lot of other techniques do. Now, there are various patterns you can do to embed historical state into your application state itself. You can keep records with the time started and the time suspended on your database tables. I mean, lots of people do that, right? They have the dates on the effectivity dates on the database tables, things like that kind. I've got a whole bunch of patterns on my website that talk about how you can do this in a nice use objects to do this in a way that gives you a nice API for manipulating that. And that is useful and necessary for many systems. But if you really want to be able to dig back into past states, if you have an event log, you can always do that, even if you didn't design your system with that in mind in the first place. So that historical capability is very strong. And of course, we know how useful that is in software. If you want to go back to the state of your code 6 months ago, you just do git reset, put a check-in number, and you can roll back and see what it looked like. And then you can diff between what was there and back and forth as well. So historic state is a very powerful feature. Now, another interesting thing about doing something like this is that when you have a system with event sourcing in place, it makes it really easy for you to then populate other systems in order to handle updates. Because you've got a single stream of events that you can then pass on to those additional systems. And this, in fact, leads to a whole style of application out there, that's architectural style, called CQRS, which separates the processing of updates from the provision of queries. Now, events aren't necessary for CQRS. You don't have to use an event-sourced approach, but the two naturally go together. And most times I hear people using CQRS, they're using event sourcing as well. And this gives us the ability to, for instance, have multiple query systems, which can be very handy if your system has a very high query load and complex updates. So you can actually do all the work in the update and then send off to multiple query loads. A particularly interesting approach of this is that it actually allows you to have different schemas in your different query areas. So you can actually design a separate schema for each of your different query needs. So some might want to include a lot of historical information and others not. Again, having the event log allows you to process this all in different ways. But there's a problem. And it's a problem that I alluded to already in terms of microservices. If you've got this kind of system, you lead to this problem of inconsistencies. Some events will have got into one system and not into others. So as a result, you lose your strong consistency and you end up with eventual consistency. Now, in fact, there are other problems as well with CQRS. It's a technique that with the appropriate problem and with skilled hands, it can be quite effective. And I've certainly come across people who have used CQRS and found it very valuable. But I have to say it is the minority of people I've talked to that have used it. And I'm not saying here that I've talked to kind of any old developer. I've talked to developers that I think are at least in the upper quartile. And I would say that most of the people that have used it have gotten themselves into trouble. CQRS is difficult to do well. And so you should be very wary about using this approach. I mean, I'm not saying don't use it, because there are definitely cases where it's very applicable, but you should sort of wear extra strong protective goggles and all that kind of stuff when you use it. We have definitely seen people get into a lot of trouble with this. But even without that, this notion of being able to support variant output states, because basically anybody can consume that event log and build their own application state, and those application states don't have to be the same. That's a very valuable property of event sourcing. The event log can be consumed by multiple systems that can build their own view of the world. And that can be handy for all sorts of different reasons, but are not necessarily connected to CQRS. And of course you've got the distribution support. If you need to build a distributed system, such as if you're using microservices, then events make it a lot easier. And again, go back to that thinking of using source code control systems. How does Git work so well as a distributed system? It's because it has this notion of being able to deal with logs. Now, there's an important complexity here, of course. What happens, what's the equivalent in general of a merge? I mean, the reason that Git works so well with merging, and we've all had difficult Git merge conflicts to deal with in the past, I'm sure, it's not always straightforward, right? Is in the end, its view of its data structure is merely a big blob of text. And if it's a binary, all bets are off, right? But if it's text, it can do a lot. But it's not perfect, and it's really a relatively simple data structure. A lot of the data structures we want to manipulate are more complex. And we have to think, what does it mean to get a conflict? And what does it mean to merge? Can we merge? We have to raise those kinds of issues when we go down the distribution path. But if we can come up with some sensible diff and merge facility, then we've got some really powerful tools that we could use. Even if we can't automatically merge all the time, if we can give the user a UI that allows them to merge two states in a sensible way, then we begin to talk about some really quite capable features. And in many ways, one of the things that most interests me in event sourcing is the sense that why shouldn't we give our users the kind of capabilities that we get from source code control systems? On the whole, we haven't given them to our users. And I mean, I hated doing this. When I'm putting slides together, I have no way to diff two presentations in Keynote in some sensible way. Even in a silly way, just to know which slides have changed would be useful at times. I store my presentations in Git because I like to have that history, but it's undiffable. And that definitely reduces its effectiveness. And I think we should think more about how we give our users the kind of facilities that we now take for granted as programmers. So I've talked about this notion of an application state and a log. And one of the interesting things is that we can really separate these things out. Separate them out to the degree that we don't actually have to keep the application state on disk. Usually when I talk to people about this kind of thing, the application state is a database. You know, it may be a relational database or whatever your database of source is, it's a database just like you work with. But it can be useful to say, let's actually treat that application state as purely an in-memory structure. And if something happens and the computer crashes, I can always rebuild it from the log. Now this opens up a whole new way of thinking about how we can process and architect our systems. It's an approach I refer to as a memory image, and I've seen it used rarely, but really quite intriguingly when it's been pulled off. I first came across it because it was the way that Smalltalk holds all its code. It did everything for a memory image, and any old Smalltalkers in the room will remember that. And that gave it some very nice capabilities that were really revolutionary at the time. More recently, there's a great example of a system, and you can find it via that link on my page, for stock trading called LMAX. And they used a very high performance, low latency system that did really very complex business logic, and it relied on the fact that it was running all the time in memory. It was run as a single threaded Java system, because it had to be single threaded to get the maximum performance, and they could process a ridiculous amount of transactions just on commodity hardware. And it was very interesting when they talked about this, because it totally subverted what most people thought. You think you need to have lots of processes and maybe some actor-based structure. Well, they tried that, and they measured it, and they found it didn't work terribly well. It was much better just run a single thread, providing they could get all their working set into memory. Well, a hell of a lot fits in memory these days. Has anybody gone to the very simple website, doesn'tfitinmemory.com? It's really quite staggering how much you can get in memory. And then if you can get it in memory, then you haven't got to do any database mapping. You can build any data structure you like, however complex, and you can manipulate it really, really fast. The only thing that you have to do is make sure that you do event sourcing and you can rebuild the system from the logs when necessary. What commonly people do, of course, when they do this, is they don't replay every event since the beginning of time. Conceptually you do that, but it's like, again, what the version control systems do. They don't actually do that when you check out some weird branch. They actually store snapshots of the application state. And it's transparent to you. We don't know that the transports, unless you're going to dig around in the .git directory and start futzing around there. But it feels like you're getting all the commits since the beginning of time, but it's actually caching application states. And that's what they do. LMAX would cache at the end of every day. They'd write out their application state, but if it crashed in the middle of the day, it would bring up that application state and then replay all the transactions up to that point. And it was fast enough that they could do that confidently. They had failovers and things like that, but again, using event sourcing helped them have hot failovers, because they can take the same event and apply it to more than one instance. So they had could easily hot swap at a very low speed latency time. So I think this approach is, I've been saying this for years, I think this approach is going to be popular soon because of the degree of memory that we're getting. You may have heard Adrian Cockcroft say, forget about microservices, we're talking about teraservices now, because we're talking about boxes with terabytes of memory attached. And I think this is going to be I'm going to predict again that this will become a more popular technique. I was wrong last time, so take that with a pinch of salt. But I think the in-memory processing aspect of this approach is really quite interesting. Now then, another thing, and again, if you think in terms of source code control, one of the nice things about this is we can take a production database and we can say, what happened? Let me investigate if something else happened. Let's copy it over to some alternative state, and then take that alternative state, blow away the application state, take the event log, and weave in an event that didn't happen. You might think, what would be an example of this? Actually, it was one of my a very good example of using this. It was on a payroll system. What happens when you find out you're in some highly unionized automotive factory, you've paid everybody their payroll run for last November, and now somebody says, oh, so-and-so didn't work the hours that we said. He worked an extra 4 hours. That kind of thing would cause a huge amount of complexity, because they had to figure it out by hand. And the consequences could be huge. That 4 hours could send you over an amount that gave you an extra day of vacation, or qualified you for some different pension rights. The consequences of that change were very complex to calculate, and people could spend a day or two figuring out what was going on, and of course lots of room for error. But in this approach, you could just go back, remove the bad event, put a new event in, and then having done that, replay the application, and you've got a new application state, which is not a real application state. This doesn't exist, but it's what the application state should have been had that event actually been processed correctly. And then you need some way to look at the diffs. For our payroll system, looking at the diffs was relatively straightforward because in the end it comes down to money in accounts. So we could just look and see how many difference is it in terms of a monetary system. That is not, a common case, but it can be incredibly powerful when you use it well. And I've seen it used a few times, and it does take, it can take a long time to process the events to do that. And I remember people think, performance-wise, oh my God, it can take minutes to calculate this. But the alternative is a human being taking days to do it. And so you're prepared to pay that price. So that working through of alternative results, that's another very useful consequence of this approach. So these are all things to consider. If any of these or some combination of these sounds like something useful, then you should start thinking about using event sourcing. How many people, we had the hands up earlier on, how many people have built a system using this? Okay, so just keep your hands up for the moment. And leave your hands up if you felt it was a good choice for what you used it for, and you would do it again for that project. Not seeing many of those hands go down. Okay, that's just a quick sort. Not many people, but it clearly was quite successful for them. But there are some problems to think about. And it would be remiss of me, because I'm me, I can never talk about the good thing without also talking about the bad thing. Choices of architecture are never simple, good, bad. It's always a case of trade-offs and context. So what are some of the disadvantages of event sourcing? Well, top of the list, of course, it's unfamiliar. It's not a technique that many people know how to use. And as a result, the programming model is unusual. The idea that every change has to be turned into something that's a processable thing, stored away, and then I have to apply it. It's actually not that hard once you get used to it, but it initially kind of feels a bit unusual. And that unfamiliarity is enough to throw some people. The second point is actually one of the biggest dangers. And it's a kind of subtle point. A lot of people, when they hear about event sourcing, they think, in order to do this, I need to have asynchronous processing of my events across my different parts of the system. Now, sometimes that is the right thing to do. Microservices, for instance, is a case where you kind of have to embrace the asynchrony to get decent performance. But a lot of the time you don't need asynchrony. There's no inherent reason that you have to use asynchronous processing for event sourcing. Again, think of Git. When I'm doing the local commit and going just git commit, is it asynchronous? No, it's a completely synchronous operation. There's asynchrony going on when we push and pull and we've got multiple repositories and all that kind of stuff, but the actual basic commit and thing is not. If I'm using a centralized version control system, remember Subversion back in the day? That was, again, a synchronous operation, right? So there's no reason why you have to be asynchronous to use event sourcing, but I've often heard people say that the two are inherently linked. In fact, one of the problems is I've run into cases where people said, we have used event sourcing and it was a disaster. And I kind of probed a little bit more because I want to understand how these techniques don't work. And then I'd say, well, because all the asynchrony involved. Okay, so it's not the event sourcing is the problem, it's the asynchrony, which I know is a known problem, so that's a known complexity issue. Another one that comes from this, and it's kind of similar kind of situation, is I've run into situations where people say, the event log is my source of truth, therefore I'm not going to keep an application state. Every time I want to know anything, I'm going to replay all the events. Now, don't do that, right? You pretty much always will have an application state. It's only populated, you only rebuild it when you have to. I mean, it's just like with Git, right? I mean, you don't operate raw on the stuff that's in the .git directory. You have your working copy that you operate with. And in fact, most of your applications are unaware of the fact that there is Git in the background. I mean, clever IDEs and editors will have some kind of Git manipulation mode, but most of their operations completely ignore the fact that Git's present. External systems that aren't event sourced are a problem. If I'm calculating, take the payroll example, I'm maybe stretching this a touch, and I'm paying I have to do some currency conversion for some reason. And if I have to rebuild the application state from 6 months ago, am I accurately going to get the currency that I actually used 6 months ago as a currency rate? Now, there are ways around this, right? I can make sure whenever I query an external system, I actually keep a copy of the thing so I can always reconstitute that event accurately. But it will certainly play havoc with the alternative situations where the timing might change and there's no way I can tell what that past state was. External systems tend to complicate matters. A particularly subtle problem is identifiers. If you're creating things and giving them identifiers that are going to be exposed outside your system, you've got to make sure that they always calculate the same identifier if you replay the events. And that can be a bit tricky. That can trip people up. And the schema of the events themselves, because they have to be replayable all the time, your software has to be able to deal with the fact that if you need to change the schema of the events, you still have to be able to populate things. And I've seen that get people into trouble as well. So there are definitely problems and subtleties with this approach to be aware of. What unfortunately I can't give you is a really great sources of information about how to do this technique. I wrote a bit about it in the article referenced there, but that was many years ago. It was back in almost 10 years ago I wrote it, and it wasn't very complete. I was looking to actually turn a whole book of that stuff, but I ended up writing the DSL book instead, and I haven't had the energy to go back and work with that. I've heard of a few people starting to write books on this kind of technique, but lots of people start books. It's much harder to finish them. So unfortunately, there's not a lot of information out there on how to do this well. But I think of the guide of what does a version control system do is actually a very useful guide to help you at least begin to operate with this. And as you saw from the hands, a few people have used this technique and found it worked well. And another point I should stress, you don't have to do this to every part of your system. Often where I've seen this, it's only used in one or two areas where they really needed those valuable features that I mentioned. Often to do with accounting for money, because money is important and it's easy to measure, so people tend to be focused on it. But it's a worthwhile technique to bear in mind. So that's event sourcing.